Alright, so we're going to wrap up kind of what we did last week, talking about polygon angle sums, and then get into our next topic, which is lines and equations of lines. So if we're looking at the angles of a polygon, we're talking about the interior angles, and a really helpful diagram to draw is triangles. So if I have a triangle, obviously there's one triangle that fills it up. If I have a quadrilateral, I can put two triangles in it, pentagon, and we'll also look at a hexagon. So there, my quadrilateral, my two triangles, each has an angle sum of 180 degrees. My pentagon has 3, and then my hexagon has 4. And so if we were to use some inductive reasoning, we would come up with the conjecture that the sum of the measures equals the number of sides minus 2 times 180 degrees. And the 180 comes from the number of the sum of the angles from the triangle. The n minus 2 is how many triangles that don't overlap that we can fit inside there. So we can use that property down the road to figure out what our angles are going to add up to for any polygon. If it's a regular polygon, the angles are going to be the same, but this is a general case and it'll work for any type of polygon. Alright, we also have the exterior angle sum theorem, which states that if you take the exterior angles and you add them up, you're going to get a full rotation. You have to go all the way around. So that's going to be 360 degrees. So anytime it doesn't mean they're all the same, but if we take the exterior angles, we will add them together and get 360 degrees. And we'll look at a proof for that later in class. So here's an example problem. So a regular polygon means the sides and angles are congruent. And we can use that fact and what we just talked about to solve for the missing angles, and not in this case solve for the sides because we don't have any linear information, but we can figure out the angles. So all the angles are the same, all the sides are the same, makes it a regular octagon because there's 8 sides. And if I wasn't remembering my my formula, that's how many triangles I can fit. And so there's 6 triangles in there. The sum of the interior angles given by our equation is n minus 2 times 180. Well, that's 6 times 180, so that all of them add up to 1080 degrees. Well, I know there's 8 of them, and so they're all the same, which means that I can take my number and divide by 8, and I'm going to get that 135 degrees is one angle. If I was further asked about one of the exterior angles, well, that's 180 minus 135 is 45 degrees, and if I wanted to just check my exterior angle sum theorem, there's all my exterior angles. They're all 45 degrees. 45 times 8 is 360. So it all works out just like we knew it had to, given our theorems on the previous page. Alright, so that might be one way that we're given it. We're given the number of sides and we want to figure out the sum of the interior angles. It could be the opposite. We could be given the sum of the angles and have to figure out the sides. But we start again with our equation. The sum is 720. And I know that's also equal to n minus 2 times 180. Well, once I have that set up, I just solve for n. I divide by 180 and I add 2. And I get n is 6. So that is going to be a hexagon. So these are really two important properties. They allow us to go back and forth between finding the number of sides, or if given number of sides, find the sum of the interior angles. Alright, so moving on, we're going to talk a little bit of algebra. So this is going to be familiar to you. We have equations of a line, and there are 2 forms really that we look at that are most beneficial to us. So we have slope-intercept, y equals mx plus b, where m is the slope or the rise of the run, and then y is the y-intercept, where it crosses the y-axis, is my b value. So if I had a line, there's my b value, and then my slope is my rise and my run. So my run is my horizontal movement, my rise is my vertical movement, and the y-intercept is when x is 0, so that first part of my ordered pair, and y is where I cross the y-axis, we normally call b. Alright, I also have point slope form, which is y minus y1 equals m minus quantity x minus x1, where y1 and x1 are a point that we know. Our slope is the same, given as m, and that is our ordered pair, the point that we know, or contained on the line. Now these are really the same form of the line. Y equals mx plus b is a special case. So if you were to plug in 0 and b for y1, x1, and y1, you're going to get y equals mx plus b. So it's the same thing that we had before. So it's really one form of a line. But we often it's beneficial to have the slope-intercept form, and so we will specify that as a different form of a line. Alright, we also have standard form of a line. ax plus by equals c. This isn't very beneficial right off the bat to us, but we can transform it into one of the other, into slope-intercept pretty easily and be able to use it. So a, b, and c are integers, which means that they're whole numbers. They could be negative, but they're not fractions, they're not square roots. So let's look at an example. Put this into standard form. So I have y equals 2x plus 6. Pretty simple. I need to bring the x's and y's together. That's not quite there because my x has to come first, so it looks like negative 2x plus y equals 6. So that's standard form. Now it doesn't tell me anything about the slope, it doesn't tell me anything about the y-intercept, and explicitly we'd have to solve for it to be able to get it. Alright, the other big topic is parallel and perpendicular slopes. So the first one's pretty easy. If I have a slope of rise over run, and I have the same slope between two lines, they're going to be parallel, right? They're never going to catch each other. So if one goes up a little bit, the other goes up the same amount. If one goes across a little bit, the other goes across the same amount. So parallel lines have the same slope. Perpendicular lines are a little bit trickier. So often people remember that perpendicular lines, their slopes are opposite reciprocals, but let's look at why that is. So if I take two lines, first off, that's defined as a positive slope. So as I go from left to right, I'd be going uphill. And that's defined as a negative slope. As I go from left to right, I'm going downhill. And I want them to be perpendicular. So I draw a couple of pictures. So I'm given that they're going to be perpendicular. I want to see why that's true, that I have opposite reciprocals. Well, if I use a little bit of our geometry, I know that the angles 1 and 2 are congruent because they're vertical angles. And then if I think about what's happening here, I have angle 3 and I have angle 4, which are actually the same angle, because 2 and 3 add up to 90 degrees because they are, I'm looking at perpendicular lines. And then 1 and 4 have to add up to 90 degrees as well because they're in a triangle and already have a right angle in there. So remember, all the angles in a triangle add up to 180. Well, 1 and 4 are going to have to add up to 90 as well. So that turns out that 3 and 4 are the same, and by the same process I get down here that angle 5 is the same as angle 2. So what I really have is similar triangles. So the triangle down below attached to the green line and the triangle above attached to the orange line are similar, meaning that the angles are congruent and the sides are going to have a common ratio. And so if we try to match up the sides, we see that side X is on the side with the angle with one tick mark, 5, and then the 90 degrees. If I was to put that on the other side, it goes on the vertical part, and then Y goes on the horizontal part. So my horizontal and verticals have flipped, which means the slope of my orange line is negative X over Y, and then the slope of my green line is Y over X. So you can see that we have negative reciprocals of our slopes if we're going to get perpendicular lines. So if I had a slope of 2, the perpendicular line would be negative 1/2 as I got through it. Alright, we'll do a couple of examples. Given 2 points, what is the equation of the line? So a couple things I need to figure out. I have another one. What is the equation of a line perpendicular to y equals 1/4 x minus 6 through the point 8, 6? Alright, so if we look at the first one, the first thing I got to figure out is the slope. So I figure out the slope as we've done before. So it's 3/4, and then I have a couple of options. I can use slope-intercept, I can use point slope, but I have to somehow plug it into one of our equations of line that we have. So I used point slope because it's easier to do right off the bat. So I picked a point 3 and 8, and I used my slope, and I put them in to the points that I had. I could have done it the other way. I could have picked the other point. That would have worked out just the same. They would have worked out to be the same equation, same line. We could go through the math and break it down to the same thing, but it doesn't really matter which point I pick as long as I'm consistent in my naming of x1 and y1. If I look at the next one, well, there's my slope. So a perpendicular line is going to have the opposite reciprocal, which means that it's going to be negative 4 over 1. And once I have the slope, I plug it into my point slope form. So I only have one point to pick from, where y1 is 6 and x1 is 8. I plug those in and I get my equation. Alright, last example here. Given this point and a slope of 2, determine the y-intercept. Alright, so a little bit different. I'm looking for that b value in what I had before. So if I take my equation of line, that's point slope, so I'm given the slope of 2 and I'm given a point, and I want to put it into my y equals mx plus b form. So I do a little bit of simplification and get y plus 3 equals 2x minus 6. Subtract 3 from both sides. And now it's in my y equals mx plus b form, and the place of b is the 9. So that is going to be my y-intercept. I could have done it a little differently if I was really trying to be fancy. So I would take my points, -3 and 3, and I know that the y-intercept is a point on the line and it has the coordinates of b and 0. So that becomes my y1 and my x1. So I plug those in, set it equal to the slope, and I solve for it, and I get the same thing. The second method is not usually used as much as the first, but you should know that you could do it with just the slope. It still works the same because you're using that point of 0b for the y-intercept.